Well, okay, so now this is chapter number 9, and we're going to start talking about how to solve for the current stock price, also known as P0. Okay, so in the textbook, when we say P0, that means the price right now at time 0. But specifically, when we solve for P0, we're solving for the intrinsic value, which is the fair market value. It tells us how much that this asset actually worth right now. Okay, so it gives us the worth. Gives us the worth of this investment. Okay, since we're solving for the worth of the stock, it tells us what is the worth of one share of stock. And from the irrational investor's perspective, it should also be the maximum price that a rational investor is willing to pay. For example, if my calculated P0 equals to $10 for stock XYZ, then that should be the highest price that a rational investor is willing to pay. So if currently the stock is traded at a price higher than that, let's say $13 per share, then I should choose to not buy. Okay, I want to buy low and sell high. I should only want to buy if the actual price is equal to or less than my calculated P0. Okay, so how do we calculate for the P0? Mathematically, it's always the same whether you are solving for the intrinsic value of a stock or bond. Okay, so we always want to find the NPV of all of this investment's expected future cash flows. So for example, in chapter 8, when we were solving for the price of a bond, right, same logic, we start with by looking at, okay, if I were to buy this bond right now, what kind of future cash flows would I get, right? Once I identify all of the relevant future cash flows that's related to this investment, then I would discount all of the future cash flows back to net present value. Well, this net present value is the price of my investment, okay, the intrinsic value of the investment. And this can be any investment. It can be a bond, a note, a share of stock, okay, it can be common stock or preferred stock. The fundamental is always the same. Okay, so with bondholders, you have two sources of future cash flows, which are coupon payments and par value. Right? And that's why we discounted those cash flows back to present value. Well, the NPV is the intrinsic value for a bond. And now when we are solving for the stock price, we're going to use the exact same logic, except that for stockholders, you're not going to receive coupon payments and you're not going to receive par value because there's no maturity date. Okay, stock do not have maturity dates. So for that reason, we need to first of all, okay, so since stocks do not have maturity date, fundamentally, if you were to buy a share of stock, unless you are able to figure out a future stock price, okay, otherwise we're going to assume that you will hold on to your stock forever until the year of infinity, okay? So fundamentally, the P0 or intrinsic value of a share of stock is just the net present value of all, what? All of the future dividends until when? Until the end of year infinity, okay? Because stocks don't have maturity dates. Okay. But fortunately, if you are able to identify a pattern in the annual dividends, you chances are will be able to use one of the 3 dividend models here to solve for the P0, okay, also known as the intrinsic value. So we'll have zero growth model, also known as the constant dividend model. Okay, we also, the second model is constant growth, that is the constant dividend growth model. Okay, the third model is called differential growth model, or sometimes it is called a supernormal growth model in some other textbooks. Okay, but let's look at the easier scenarios. Okay, but so when you have not just the dividend information, but you're also able to obtain a future stock price. Okay, when you are also able to obtain a future stock price, then your calculation for the P0 is simplified. Okay, so let's look at this numerical example. Okay, so if you know not just the dividend information, but you also know a future stock price, whether it is in year 2, in year 3, or year 10, at some future date, then we can assume this. But before I tell you that, let's look at this numerical example. And I would like to see what you guys can remember from Finance 330, okay, and 332. So now we'll have a company called XYZ that predicts the following dividends. So it predicts that dividend in year one is going to be $1. So let me draw a timeline, okay? So let's use the timeline to visualize our relevant cash flows. So this is time 0, time 1, time 2 versus time 3, okay? Or you can say years 1, 2, and 3. So based on the information, it says dividend in year one is $1. So when we say in year one, we mean at the end of year one, okay, which will occur here. So your D1 equals to $1. And we're told that in year two, it is $1.20. So this is your D2, okay, dividend paid in year two. That means at the end of year two. So it will occur here, $1.20. And dividend in year three is $1.25. So that would be here, 1.25. Okay. And by the way, just so we're clear, in the real world, sometimes the companies will pay quarterly dividends rather than annual dividends, right? So the common approach is that we'll add all of the quarterly dividends during that 1 year, all the quarterly dividends paid in year one together. Then we'll use that total dividend paid in that 1 year as our D1. Okay, that's just the common approach. Okay, so other than the 3 dividend information, we're also told that if the projected stock price in 2 years is $20 per share, so this tells us that P2, right, price at the end of year 2 is expected to be $20 per share. So that's at the end of year 2, that will be here, okay, on the timeline. So I will include that $20 here. Okay, that's a part of cash flow 2. So now, in order to use that fundamental logic that says that P0 is just the net present value of all of the relevant future cash flows. So let's identify our relevant cash flows. Are all 4 numbers given to us here relevant cash flows? Are all 4 numbers relevant cash flows?
No, the 125 is irrelevant, should be.
That's the correct answer. The $1.25 or your D3 is irrelevant. Why is it irrelevant?
It happens presumably after you sold the stock.
Exactly. So let me insert a slide, okay? And let me delete this. When a future stock price is obtainable, okay, we typically assume that, that we will sell our stock at that price and time, okay? So for example, in this case, we will assume that we sell our stock in year 2 at $20 per share. And how would that impact whether D3 is relevant? Note that once we sell our stock in year 2, we will no longer own the stock in year 3, okay? And that's why when the company pays dividend in year 3, since you will no longer own the stock, and therefore D3 is not a relevant cash flow for you, okay? Because you will no longer own the stock. If you don't own the stock, you will not receive dividend in year 3 when company pays dividend in year 3. So that means to solve for the P0 in this particular case, you only have cash flows 1 and 2 that are relevant. So you're based on the timeline, your cash flow 1 is going to be that $1. Well, your last relevant cash flow is cash flow 2. Well, the last cash flow always has 2 components. It will include the dividend paid in that period plus the stock price that you cash out at. Okay, so cash flow 2 will include your D2 plus P2. So your D2 is $1.20, while P2 is $20. Then that means your cash flow 2 together should be equal to $21.20. there's no cash flow 3, okay, because of what we have just said here. When we're able to obtain a future stock price, we'll simply assume that we will sell our stock at this price at this particular time. So once you sell your stock at the end of year 2, you will no longer own the stock in year 3. So when the company pays dividend in year 3, you will not receive that dividend in year 3. Okay, so we don't have cash flow 1 and cash flow 2. So now to solve for the P0, we also need to have our discount rate or required return. And in this case, it is 18%. Okay, so we'll use the function key, the cash flow function key, press second and clear work. So the first relevant cash flow is cash flow 1, right? So we're going to scroll down. We're going to skip cash flow 0 and go ahead, go to cash flow 1. Cash flow 1 is $1. So down arrow twice. Now we enter cash flow 2. We already know that is $21.20. If you don't know that, you can add that here. Okay, so 1.2 plus 20, okay, equals. So you can do that calculation here before you press the enter key. Okay, unfortunately, there are only 2 cash flows that are relevant here. So to calculate for the NPV, which is our P0, you press the NPV key, enter discount rate 18%. Okay, so 18, enter, then down arrow 1 time, then press compute. Okay, $16.07. So when we're talking about money, we round the number off to the nearest cent. So let me erase this. Okay, so we see that when we have both the dividend information and a future stock price information, the calculation is simplified. Okay, but what if we don't have a future stock price information? Then what do we have to do? We'll have to assume that we'll hold on to our stock forever, okay, until the year of infinity. So in that case, we will try to see if the dividend fits into one of the 3 dividend models. So typically what we do is we'll try to use history to predict the future. So a lot of times we'll use historical dividend information. Okay, so we'll graph the annual dividend. In this case, your x-axis will be year. Okay, your y-axis will be the annual dividend notated by the capitalized D. So once you calculate your annual dividends in the past few years, let's say 5 years, and you graph that annual dividends, and while the annual dividend graph looks like this, okay, then congratulations, you have the most simple scenario. Okay, so the dividend does not grow at all. Okay, it's 0 growth model, or you can also call it the constant dividend model. 0 growth model, 0 growth, or constant dividend model. Either way, it is fine. Okay, the dividend is constant. Okay, it does not grow. So either 0 growth or constant dividend model is fine. In this case, your D1 equals to your D2 equals to your D3. Okay, they are all the same. When dividends remain the same, we have annuity cash flows. Since stocks don't have maturity dates, we have perpetuity cash flows. So it's not just any simple annuity cash flows, but the special case that we talked about in chapter 4, the special case that is annuity cash flows that last forever, and technically speaking, it is called perpetuity cash flows. Okay, we don't have maturity dates. What we have here is called perpetuity cash flows. So how do you solve for present value when you have perpetuity cash flows? This is again also it's discussed in Finance 330, and we reviewed that in chapter 4, right? So we start with the present value of annuity equation. Okay, so how do you calculate present value when you have annuity cash flows? There we go. So we'll start with C, which is the annuity cash flow outside of the bracket. Then we multiply that by the bracket. Inside the bracket, we have a numerator and the denominator. Okay, so this is the numerator. 1 minus 1 over 1 plus r to the power of t. and the whole thing is divided by R. Okay. So this is the present value of annuity equation. But when the annuity becomes perpetuity, this equation actually gets simplified, right? So if we said as t approaches to infinity, because we have cash flows that last forever, right? As t approaches to infinity, what happens to this term in the blue circle? The 1 over 1 plus r to the power of t will approach to 1 in the numerator remains the same. But in the denominator, when this t approaches to infinity, the denominator explodes and becomes infinity. So when you have 1 over infinity, by definition, it is equal to 0. So that means when we have perpetuity cash flows, that term in the blue circle disappears and becomes 0. So your present value of perpetuity cash flows is calculated as in the numerator. Okay, going back to this original equation, we'll have C multiplied by 1 in the numerator. So that's just C. Then minus C times this 0, right, in the blue circle. Anything times 0 is just 0. So that's the numerator. Now, denominator, we still have the R. So we simply copy that R down here. So the present value of perpetuity cash flows can be calculated as simply as this fraction. The C is the annuity cash flows. Okay, now in this chapter, the annuity cash flows are your dividend payments. So in most textbooks, we're changing the notation a little bit. Okay, so rather than using C divided by R, we say it is D divided by R. Okay, because it is the annual dividends that are constant. Okay, that's the annuity cash flows here in the numerator. But one common mistake, though, is that while this is a very simple calculation, you need to make sure that the unit of measurement in the numerator and unit of measurement in the denominator are the same. So if the authors give you quarterly dividend information in the numerator, you need to make sure to plug in quarterly rate in the denominator. Okay, do not mismatch them. Okay, don't plug in quarterly numerator and annual denominator, then you will end up with a wrong number. So just read the question carefully, okay? Make sure to match both the numerator and denominator with the same unit of measurement. Okay, so let's look at this numerical example. Okay, this is a very simple one. So conceptually, we know that preferred stocks pay fixed dividend payments, okay? Preferred dividends are almost always fixed. So when you are being asked to solve for intrinsic value of any preferred stock, then you should know automatically that you have 0 growth. Okay, you have 0 growth. But over here, the authors even tell you that we have fixed dividend payments. Okay, so dividends remain the same, and it is $4.50. Okay, it should be obvious that based on this information here, we'll have the 0 growth model. Okay, and this is our D, our annual dividend. So P0 equals to D divided by R, and our numerator is 4.50. Now this is annual, okay, annual numerator, and that means in the denominator, we need to make sure to plug in annual R, and the required return is 12%, so 0.12. So once you plug in those numbers to your calculator, you should end up with $37.50. Now, fortunately, for those of you who want to avoid equations as much as possible, you can still use function keys, okay, for this one, because it is very simplified. So what you can do is to use those 5 function keys located on the 3rd row of a financial calculator. Okay, so we know that with 5 variables, you can solve for any one of the 5 unknowns, right? You can solve for any one unknown when you enter inputs for the other 4 variables. So if we're solving for P0, we know that we're computing for the present value, right? So let's figure out what the other 4 variables should we enter as the inputs. So we'll start with the obvious. The $4.50 dividend, that's something that occurs regularly and is always the same amount. By definition, that is annuity, right? And that's payment. So 4.5, $4.50 is our payment. And the required return, the IY is 12%. Okay, so IY is 12%, enter 12, press IY. Now, what is the N? Again, stocks don't have maturity dates. Okay, so technically speaking, n should be equal to infinity. But the closest we can get is to enter a very large number. So let's enter 99999. Okay, enter many nines. Then we'll press the n. Now, what should be the future value? It should be equal to 0. Perfect. Okay, so because stocks don't have maturity date, so that means you should never, in this case, fundamentally, we're assuming that you will never be able to cash out. You will never be able to sell your stock. Okay, you're going to hold on to the stock until forever, until the year of infinity. So you will never sell it. In that case, the future value is $0. But the truth is that even if you enter your future value equal to your dividend, if I enter as $4.50, but when you do that, you are telling your calculator that 9 years later, I end up selling my stock at this price. But the thing is that when you discount $4.50 back to present value from a future value that occurs so far away from now, once you discount that $4.50 future value back to present value, you end up with 0, okay? Something very, very, very close to 0. So the truth is that whether you enter future value as your dividend or $0, it should not impact your final answer. So when I hit compute present value, $37.50. And if I change my future value to the correct number, which should be $0, and I hit compute present value, it gives me the same answer. Okay, that's because when you discount a future value that occurs so many years from now on, and you discount that back to present value, you are going to end up with something that's fundamentally 0. So why is present value a negative cash flow? Because in order to receive $4.50 in dividends every year for until eternity, this is the price that you have to pay right now to invest or to buy the stock. Okay, so if you are using the function keys, the present value will be a negative cash flow. But if you are using the equation, all the numbers are positive. Okay, so what if we solve for not the P0, but we're asked to solve for the R, or the required return instead? This should be pretty simple, okay? So your corporation is trying to issue preferred stock. Again, when you see preferred stock, that should be an indication that we have 0 growth model here, or constant dividend case here. So to decide the appropriate required return, or something for the R, you find a comparable firm. So what is a comparable firm? A few chapters down the road, we will actually go through a process to identify a comparable firm for our case analysis. But for right now, you just need to know that a comparable firm is a similar firm that operates in the same industry. But in the future, a couple of chapters down the road, we'll actually go through a process to identify a comparable firm for our case analysis. So we don't know what required return that our investors want. Okay, therefore, we find a comparable firm that's very similar to our corporation. Okay, we'll do some calculation to figure out what their investors demand as the required return per year. Right, then we'll use that as the required return for our investors, since we don't know what our investors want as the required return. Okay, so with preferred dividends of $3 per share, so this is our D. Okay, this is D. Well, current price, this is our P0. Okay, so if you're asked to solve for the R instead, and we know that this is the 0 growth scenario, well, the equation is here. Right? We know that the P0 equals to annual dividend divided by R. Now, all we need to do is to rearrange this equation to solve for the R. And how do we do that? The easiest way is to swap or exchange your P0 with the R. So we simply now have R on the left-hand side of the equal sign, while P0 is your denominator. So let's plug in the numbers. D is $3 in the numerator. P0 is 25. Okay, 3 divided by 25, you will give us 12%. Now, similarly, for those of you who prefer to use the function keys, even though honestly, in this scenario, it's easier to just use the equation, but you can still use those function keys, right? If you're solving for a rate of return using those 5 function keys, you're computing for the IY. Okay, so we need to make sure to enter inputs for the other 4 variables. So we know the P0 is $25, but remember, we're buying the stock. So if you're entering using the function keys, the present value is an investment or a cash outflow. Okay. Well, $3 dividend, by definition, that is your annuity cash flows or payment. And once you buy the stock right now, okay, you'll be receiving the $3 payments every year. So your payment is positive. And the stocks don't have maturity dates, right? So N equals to 9999, okay, technically infinity. And because stocks don't have maturity date, you will not sell your stock. Okay, so future value equal to $0. Now compute for IY. You should get the same 12%. Okay, so let's look at constant growth. So we actually talked about constant growth in chapter 4 as well. And in chapter 4, let's see, constant growth. What is constant? To be specific, it is constant dividend growth. Okay, it is the dividend growth rate that is constant. Okay. So while case 1, the earlier model, it was the what? Constant dividend, okay, or 0 growth. But right now, it is the dividend that is growing at a constant rate. Okay. Now, in chapter 4, this constant dividend growth model was referred to as the growing perpetuity model, okay, or equation. So in chapter 4, I show you the derivation. Okay. So if you are interested in just refresh your memory, you can always go back to rewatch that video. In chapter 4, it is called growing perpetuity. So after going through some derivation, but before even going through the derivation, how do we know in real world that when should we use that constant growth equation? Again, you're going to, first of all, calculate your annual dividend, right? Then after that, you're going to graph your annual dividend. So your x-axis is year, while your y-axis is your annual dividend notated by this capitalized D. So in the perfect world, you're never going to see that we actually have corporations that have exactly same growth rate every single year. Okay. So in the real world, if you find a company that pays dividends, well, the dividends are growing at a relatively constant rate, that is going to be as good as we get. Okay. We don't live in a perfect world. If we were to live in a perfect world, when you graph this annual dividend, you should end up with one perfectly straight line. Okay. So the blue line represents the perfect world, but we don't live in the perfect world. Okay, so if we find a company whose dividend payments are growing at a relatively constant rate, that is going to be as good as we can get. Okay, that's good enough for us. So once we go through the derivation, which I'm not going to show you again, this is the final equation. Okay, where that says P0 is calculated as D1 divided by R minus G. So pay attention to this equation. Okay, if you're solving for P0, we need to make sure to enter D1 in the numerator. Okay, and that implies if we're solving for P1 instead, rather than P0, what do we need to plug in as the numerator? The dividend needs to be the period after the price. Okay, it has to be D2. Then the denominator remains the same. Okay, so we divide it by R minus G. Now I'll do one more. If we're solving for P10, stock price 10 years from now, guess what? We need to plug in D11 in the numerator. They will divide it by the same denominator, which is R minus G. Okay. Sorry. Sometimes when we're moving toward the corner of the monitor, the calibration is not good. Okay. So in the denominator is R minus G. So if you review that derivation, you're going to see that it really saves us a lot of time. Because if we didn't have someone who was able to transform that very long and complicated equation into this equation, we literally have to calculate for the P0 using the fundamental method, which says what? P0 using the net present value calculation, we'll have to start with D1, we discounted by 1 period, okay? Then we plus D2, we discounted by 2 periods, which means we divided by 1 plus R to the power of 2. So we continue with this by using D3 discounted by 1 plus R to the power of 3. And we need to continue this until what? Until we reach dividend paid in the year of infinity, and we're discounted by 1 plus R to the power of infinity. So fundamentally, this is how you calculate for the NPV, or net present value, right? We saw that in chapter 4. Okay. So that means if we are not able to simplify this calculation, it can literally take us forever to find the P0. But after going through the derivation that we saw in chapter 4, we saw that the whole calculation here can be simplified into D1 divided by R minus G. Okay, so rather than spending forever to find the P0, we can solve for P0 in less than a minute. Okay, so let's look at this numerical example. Okay. What time? Okay. Okay, on time. Okay, so suppose Big D Incorporated just paid. It has just paid with emphasis on this, okay? So when we're solving for P0, stock price that I should pay right now, I'm going to look at, once I buy the stock right now, what kind of future cash flows that I will get, right, after I purchase the stock. Now, this dividend has already been paid, okay, which means that if I were to buy the stock right now, I will not receive this particular 50 cents because it has already been paid in the past. And this, that tells us that this is an irrelevant cash flow, okay, irrelevant cash flow. However, we may have to use this information in order to find what is relevant to us. Okay, so this dividend that has been paid is called current dividend by definition, okay, current dividend. And notation-wise, we use D0 to represent current dividend. And you need to know that the current dividends are always irrelevant. Okay. But in this situation, we're going to use that D0 in order to find the D1 that we actually need. Because remember that to solve for P0, when we have constant growth model, we'll have to plug in D1 in the numerator. Then we discount it or divide it by R minus G. Okay. So D1 is not given to us directly, but we can find it pretty easily. Okay, so the next sentence, it reads, it is expected to increase its dividend by 2% per year. So I emphasize the key words here. It says per year. So normally when you see per year, these two words indicate that something is constant. Okay, per year, it means that something is occurring repeatedly, right? So something is constant. What is constant? Is this 2% growth rate that is constant? Okay, so that's our G. So it tells us that we have constant growth model here, okay, constant model scenario, while that constant thing is the growth rate. So G equals to 2%. So we can use that information here to find our D1 here that we need in the numerator, because if we know D0 is 50 cents, well, and that the D1 will be 2% higher than D0, we can use that fundamental future value equals to present value times the compound factor. Okay, we'll use this equation to find our future dividends. So for example, if we're solving for D1, that's the future value, okay, equals to present value, which is our D0, times 1 plus the growth rate, okay. So in this case, current dividend is 50 cents. And we know that D1 will be 2% higher. So we multiply it by 1.02. Okay, so that would be 51 cents. So that's our numerator, okay, 51 cents. So 0.51. Then we'll divide that by R minus G. R is your required return, 15%. G is that 2% that was given to us, right? So 0.15 minus 0.02. So our denominator is equal to 13%. Okay, so we can say that it is equal to 0.51 divided by 0.13. Okay, let's plug in the numbers to the calculator and see what we get. Okay. So our P0 is $3.92. And by the way, there's no function keys that you can use to solve for the P0 when you have constant growth scenario. You have to use this equation. Okay, and it's not a difficult equation. Okay, so let's continue. So how much should the stock price be 3 years from now? So we have just solved for the P0, and now we're being asked to solve for P3, stock price 3 years from now. So given that we still have constant growth scenario here, right? So we're going to go back to this fundamental or basic constant growth equation here on the right-hand side that says P0 equals to D1 divided by R minus G, right? So what I emphasized earlier was that this dividend in the numerator is always 1 period after the price. If you're solving for P0, you use D1. If you're solving for P3, that means you have to use D4 in the numerator, okay? Then the denominator remains the same, which is R minus G. But how do I find D4? I know what my D0 is. I know my dividend will be growing at 2% per year. So we'll solve for D4 by using this fundamental method that we saw in chapter 4, right? Also, that was the first time value of money equation that you guys learned in Finance 330. So D4 equals to D0, which is the present value, times 1 plus, in this case, the growth rate, to the power of 4 times. So you compound that growth rate for 4 periods. So 0.5 times 1.02 to the power of 4. So let's see what we have. 1.02 y to the x 4 times. We multiply it by the D0 of 0.5. Okay, so this is our numerator. Our D4 equals to 0.5412. Now that's because my number of decimal spaces is set as 4. Okay, so there could be, who knows, 12, 20 decimal spaces that are being calculated. So to avoid rounding error, you should always use whatever this output is as your numerator, okay? So even though when I write down the number, I might just write down 0.5412, but when I do the actual calculation, I'm going to use whatever the output that I have here, then I will divide it by, again, 0.15 minus 0.02, which is 0.13 in my denominator. So divided by, oops, let me move the calculator upward, by 0.13, okay? So it'd be $4.16. So you always round the number off only at the end, okay? So $4.16 per share. So our calculation tells us that you can buy the stock right now, okay? You can buy the stock right now. We calculated P0, right? In the first part of this slide, it was $3.90, what? 92 cents. And now we'll have to solve for P3, stock price at the end of year 3 equals to $4.16. So now we're asked to find out how much should the stock price be 3, okay, and what is the annual growth rate in price? So we're being asked to solve for the rate of change in price. How do we do that? Anybody? Bonus points. The easiest way is to use function keys. Okay, you can use those 5 function keys here. So we can assume that we will buy the stock right now at this price. So this is our present value, and it has to be entered as a cash outflow. Right? When you buy the stock, it is a cash outflow. So present value, 3.92 is negative cash flow. Now, 3 years from now, we sell or we cash out at this price. So future value, when we sell it, we get to receive the money, right? It's a cash inflow. So 4.16 future value is positive cash flow. I'm only looking at the rate of change in price, so I'm not going to include any dividends. So 0 payments, that's my dividend. What is the N? I buy right now and sell it 3 years from now. So my holding period is 3 periods, 3 years. So 3 is my N. Now I can compute my IY, which will give me the rate of change per year. Okay, and it is 2%. So that 2% rate of change in price per year is the same as the 2% rate of change in dividend, and that is not an accident. Okay, so let's make sure that we are aware of this fundamentally and conceptually. Okay. Note that when dividends are growing, at a constant rate, the stock price will grow at the same rate as the dividends. And what we saw was that the dividends are growing at 2% per year. And when we calculated for the growth rate in price, we ended up with the same 2% growth rate. Okay, but that is only when dividends are growing at a constant rate. So here, okay. So if the dividends have 0 growth rate or they have variable growth rate, then this will no longer hold. Okay, this conclusion will no longer hold. This is only true when dividends are growing at a constant rate. In that case, we'll find the stock price will grow at the same rate as the dividend growth rate. In this case, 2%. Okay, so next, how do we rearrange this equation to solve for the R? So the basic equation is this one in the red circle on the right-hand side of the screen, right? So when we have constant dividend growth scenario to solve for P0, we use D1 divided by R minus G. But now if we have to rearrange this equation to solve for the R, the quickest way is, I'll use black color, we can exchange or swap your present value with your denominator. So we end up with R minus G on the left-hand side of the equal sign. Then on the right-hand side, the numerator is the same D1, while the denominator is now the P0. Now, next step to solve for the R, we need to get rid of the negative G, right? So we'll have to move it to the other side. To move it, we will add G to both sides. So R equals to D1 divided by P0 plus G. So D1 divided by P0 plus G. So this G is what we know, that's the dividend growth rate. We know that when dividend growth rate is 2%, that 2% is also our price growth rate. So this G can also be referred to as capital gains yield, because capital gains yield measures the rate of change in your stock price. If it's equal to 2%, then that means that your stock price is growing at 2%. Okay. And that implies the first component here, D1 divided by P0, that is known as our dividend yield. Okay, dividend yield is calculated always as your D1 divided by P0, which is dividend in year 1 divided by the current stock price. But this is because this is derived from the constant growth equation. So this only holds when we have constant growth scenario, okay, which means the stock dividends must grow at a relatively constant rate. Okay, so this another example is very important. Hint, it will appear on your senior assessment test. So after this slide, I will let you go. Okay, I'm going to hold you here for just a couple of extra minutes. Okay, so this is a slightly more advanced constant growth scenario because we have delayed cash flows, and we talked about delayed cash flows in chapter 4 as well. Okay, so in a more complicated scenario like this, it requires more than one step. Fortunately, it only requires one extra step. Okay, so 2 steps in total. So XYZ Incorporated has to reinvest all of its earnings in new projects now. And therefore, you won't have money to pay to the shareholders as dividends until when? Until 10 years from now. So there'll be no dividend between year 0 and year 9. Okay, so the first relevant cash flow occurs in year 10. So D10 dividend in year 10 equals to $6.50, okay, 6.50. While dividends are expected to grow at 7% per year thereafter. So the keywords are here, 7% per year. Again, when you see words such as per year, they imply that something is constant. What is constant? The 7% growth rate in dividend, that's constant. So that tells us that we should be using the constant growth equation. Okay, so constant growth equation, since the first relevant cash flow occurs in year 10, that means if we plug that into the constant growth equation, we would solve for P what? Stock price in the year before the dividend. So we'll be solving for P9. But we're asked to find the intrinsic value right now. Okay, we need to find P0, not P9. That means after this is the first step. We need to do one more step. So let's go ahead and plug in the numbers. Okay, D10 is $6.50. R is 14%. Okay, the cost of capital is also your required return. So minus the growth rate, which is 7%. Okay, so that's the same as 6.50 divided by 0.07. Okay. Right, 14% minus 7% in the denominator gives us the 7% in the denominator. So 6.5 divided by 0.07. So that will give us $92.86. So based on what we have just calculated in step 1, we can say that we can sell our stock 9 years from now at this price, because this is P9, right? This is the stock price at the end of the 9th year. So in step 2, in order to convert P9 into P0, we have to use the basic discount equation that says present value equals to future value discounted by 1 plus R to the power of T. Okay, so again, you learned that in Finance 330. So future value is the P9. Okay, so if we use P9 in the numerator to convert it into P0, I need to discount it by 9 periods. Okay, so T equals to 9. So 92.86 divided by 1.14 to the power of 9 periods. T equals to 9. Now, for those of you who prefer to use the function keys, again, step 1, you have to use equation. There's no function keys. But step 2, you can use function keys. Those 5 function keys, again, on the 3rd row of a financial calculator. So this P9 is your future value. So I'll go ahead. I already have this as my output right from step 1. So I'll go ahead and press my FV. And I'm solving for present value. So I need to have payment. Well, there's no dividend between years 1 and year 9, right? So payment equal to $0. Discount rate 14%. N equals to 9 years. Okay, so compute for present value, you'll be $28.55. Okay, again, present value is cash outflow because in order to receive those future dividends, this is the price that you have to pay right now in order to invest and to own the stock. Okay. All right, that's all the time we have today. So don't forget that the homework of chapter 22 is due on Wednesday.